All right, so we're going to take a look at LHopitals Rule today, and this is a method of being able to find a limit of a function that was previously not either able to be done or it was more difficult than what it really should be. And so this is what we're going to be looking at. Given the limit as x approaches a of f of x over g of x, where f of x is a function and g of x is a function. So you got the numerator is considered one function, denominator is considered one function. If the limit as x approaches a of the numerator and the denominator both equal 0, then LHopitals rule is going to apply. So take the limit, and the limit is going to be when you do a direct substitution. So you're going to put a into x in the numerator, a into x in the denominator, and you end up with a 0 over a 0. Then, 0 over 0 you cannot work out. It's called an indeterminate form. And so what LHopitals rule says is that if this limit is going to be 0 over 0, then that is also going to be equal to the limit as x approaches a of the derivative of the numerator over the derivative of the denominator. And the same thing holds true if the limit of the numerator is infinity and the limit of the denominator is infinity. Then the limit as x approaches a of f of x over g of x is equal to the limit of f prime over g prime. And we're going to see how this is going to work out here in a minute. There are also some other indeterminate forms where LHopitals rule does apply. However, the only ones that are going to be tested on the AP exam are these two right here, where you have 0 over 0 and infinity over infinity. There are some other examples like 0 raised to the 0 power, infinity raised to the infinity power, and various other ones. But like I said, these are the only two that are going to be tested on the AP exam. So let's take a look at our first example here. With this, we have the limit as x approaches 0 of square root of 1 plus x minus 1 over x. Now, if you do a direct substitution here and plug in 0 for x, what we're looking at is the limit as x approaches 0 of the numerator. If you plug 0 in, you get square root of 1, which is 1 minus 1 is 0. And the limit as x approaches 0 of the denominator is also equal to 0. Now, on the AP exam, this is something that is critical. You must write these two things out separately. So you need to make sure that you make a statement that the limit of the numerator is equal to 0 and a limit of the denominator is equal to 0. You cannot just write 0 over 0 and be done. It must be written out separately, where the limit of the numerator and the limit of the denominator equals 0. So because the two limits equal 0, we make a statement that LHopitals rule applies. And you must write this out on the AP exam so that they know what property it is that you are using or what rule it is that you are using. And LHopitals rule says the limit as x approaches 0 of the numerator, or f of x, well, that would be the derivative of square root of 1 plus x minus 1. And that's going to give us 1/2 1 plus x raised to the negative 1/2. And if we substitute 0 in here, you're going to get 1 plus 0, which is 1. 1 raised to any power is 1, times 1/2 would give us 1/2. Okay, well, let's do the denominator. Limit as x approaches 0. Well, now the derivative of the denominator would just simply be 1. So this is equal to 1. So that's going to give us the limit is equal to 1/2 over 1, which is equal to 1/2. All right, let's take a look at the next problem here, which is a very similar equation to the previous one. And so if we work this out, we would say the limit as x approaches 0 of the numerator, which is 1 plus x to the 1/2 minus 1 minus x over 2. If you plug 0 in, you're going to end up with 0. And if you do the same thing to the denominator, plug in 0, you're going to end up with 0. Therefore, LHopitals rule applies. And so LHopitals rule says the limit as x approaches 0 of the derivative of the numerator, well, that's going to give us 1/2, 1 plus x raised to the negative 1/2 minus, now the derivative of 1 is 0, but the derivative of negative x over 2 is going to be negative 1/2. If you plug 0 in, you're going to end up with 0. And then we'll do the limit as x approaches 0 of the derivative of the denominator, which would give us 2x. Plugging 0 in is going to give us 0. So we're in a pinch here. We still have 0 over 0. And what that means is that LHopitals rule still applies. And so we can apply this one more time where the limit as x approaches 0, and then we take our derivative once again. Well, the derivative of the first part here is going to give us negative 1/4, 1 plus x raised to the negative 3/2, and the derivative of 1/2 is 0. Now if you plug 0 in, you get 1 to any power is 1. And 1 times negative 1/4 is negative 1/4. And then the limit as x approaches 0, the derivative of the denominator, which is 2, that is going to equal 2. So that's going to give us negative 1/4 over 2, which is negative 1/8 for our limit here. Now, LHopitals rule will continue to apply as long as you end up with a 0 over a 0 or infinity over infinity. All right, so both of the examples that we have done so far have been a situation where you had 0 over 0. All right, so let's take a look at the next problem here, where the limit as x approaches pi over 2 of the numerator, well, secant of pi over x, well, that's the same thing. Secant is the same thing as 1 over cosine. Okay. Now, cosine of pi over 2, that's 0, but the limit as x approaches pi over 2 is really what we want to look at. So pi over 2 is right here, and cosine is going to be your x value of the coordinates moving around the circle here. Well, as you move closer and closer to pi over 2, your x values are getting very small. So if you think about that in terms of a limit, 1 divided by a very small number turns this into a very large number, which means this limit is equal to infinity. And if you do the limit as x approaches pi over 2 of the denominator, which is 1 plus tangent of x, it's going to be the same thing where tangent is going to be your y value divided by your x value. Well, at this point right here, your y value is 1, your x value is 0. You cannot really do 1 divided by 0. So if you look at the limit as x approaches this number, well, if you move this direction, your x values are getting very, very small. Okay, so when you get very, very small, 1 divided by your very small numbers turns into a very large number. So this is going to approach infinity as well. All right, so therefore, LHopitals rule does apply in this situation. You end up with infinity over infinity. And so that's going to give us the limit as x approaches pi over 2 of the derivative of the numerator, which is secant x tangent x, and the limit as x approaches pi over 2 of the denominator. Well, the derivative of the denominator is just the derivative of tangent, which is secant squared of x. All right, well, let's think about this for a second, because we can do a little simplifying here to make things a little bit easier. This would be the same thing as saying the limit as x approaches pi over 2 of secant x tangent x over secant squared x. Well, we can cancel this secant with one of these. So that's going to give us tangent x divided by secant x. And let's do a little trig magic here to reduce this some more. All right, so 1 over secant is the same thing as cosine. So this would be equal to the limit as x approaches pi over 2 of cosine x times tangent x. Well, we can also use another property here where tangent of x is equal to sine x over cosine x. Well, that allows us to cancel the cosine of x, taking us down to the limit as x approaches pi over 2 of just sine of x, and that is equal to 1. All right, so the next problem here, if we take a look at the limit as x approaches 1 of x squared minus 1, that is going to give us 0. And the limit as x approaches 1 of sine pi x is going to give us sine of pi, which also is 0. Therefore, LHopitals rule applies. Now, I'm writing this out, and of course on a multiple choice question on the AP exam, you don't really have to write this out. You're just answering with the correct letter response. But I just want you to get in the habit of making sure that you make this statement that you are using LHopitals rule. All right, so the limit as x approaches 1 of the derivative of the numerator, which would be 2x, over the derivative of the denominator, which would be pi times the cosine of pi x. This pi right here is because of the chain rule. Okay. Well, this is equal to 2 over pi times the cosine of pi. And the cosine of pi is -1. Therefore, that's going to give us -2 over cosine of pi. All right, so the next one we have the limit as x approaches 3 of the tangent of x minus 3. And then we have the limit as x approaches 3 of 3e raised to the x minus 3 minus x. All right, so limit as x approaches 3 of tangent, that's going to give us tangent of 0, which is 0. And plugging 3 in here is going to give us 3e to the 0 power minus 3, which is 3 minus 3, or 0. Therefore, LHopitals rule does apply. Giving us the limit as x approaches 3 of the derivative of the numerator, which would be secant squared of x minus 3 over 3e to the x minus 3 minus 1. All right, so in the numerator, we're going to get secant of 0 squared over 3e to the 0, which is 3, minus 1. Now remember, secant is 1 over cosine. 1 over cosine of 0 is 1 over 1, which is 1. And 1 squared is 1. 3 minus 1 is 2. So that gives us 1/2 as our limit. All right, so the next one, if we look at the limit as x approaches 0 of cosine x minus e to the x, that would be cosine of 0, which is 1, e to the 0 is 1, 1 minus 1 is 0. And the limit as x approaches 0 of the natural log of 1 plus x would be natural log of 1, which is 0. So therefore, LHopitals rule does apply because we have a 0 over a 0. All right, so that's going to give us the limit as x approaches 0. Derivative of the numerator is going to be negative sine of x minus e to the x over, and then the derivative of natural log is going to be 1 over 1 plus x. So substituting 0 in here, you're going to get sine of 0, which is 0, leaving you with negative e to the 0, and that's going to be negative 1. All right, in your denominator, when you plug 0 in here, you're going to get 1 over 1, which is 1, which means negative 1 is your answer. All right, and our final example here. You may recognize this, hopefully you recognize this, as the definition of a derivative. This would be the derivative of the function sine of x. And so let's think about how we have worked this problem before. Before, we would recognize the function, write it down. We would find the derivative, which is cosine x, and then we would evaluate the derivative at the number that is in place of x in our definition, which is pi over 6 here. So we would evaluate this at pi over 6, and the cosine of pi over 6 is equal to root 3 over 2. That's how we would work this before. Now let's take a look at using LHopitals rule on this as well. So if we substitute 0 in for the h, that would leave us with sine of pi over 6, which is a half. Minus a half is 0. Plugging 0 into your denominator, we're going to end up with 0 over 0, which means LHopitals rule is going to apply. And therefore, the limit as h approaches 0 would equal the derivative of the numerator, which is cosine of pi over 6 plus h. Derivative of a half is 0. In the denominator, you have derivative of h, which is 1. So now, when you plug in 0 for the h, you end up with cosine of pi over 6, which we know is root 3 over 2. So we can also work out this definition of a derivative or difference quotient problem using LHopitals rule. It also applies in this situation.